Okay, good morning class. So today we're looking at exercise 12 and calculus exercise. No, grade 12. EX is the explanation of the exercise, of the full exercises. And it's exercise 13 on page 174. Because we're at the close of this lesson, so we will probably only do 2 sums, okay, before the bell rings. So here we are told that in number 1, we are told that f of x is equal to ax cubed plus bx squared plus cx plus d. Alright. And it passes through the points negative 2 and 0, 2 and 0, 6 and 0, as well as 30, 3 and 15. The question says determine the values of a, b, c, and of course d. Alright, so what we notice, people, we notice at this point that we have 3 x-intercepts. Can you see that, people? We have 3 x-intercepts. So we follow the formula, y is equal to a into x minus x1, x minus x2, x minus x3. Okay. Where x1, 2 and 3 are what? X-intercepts. There are your x-intercepts. How do I know it's x-intercepts? The corresponding y values are 0 there. So what we do is we say y is equal to a into x minus minus 2 is plus 2, x minus 2, and x minus 6. So in order to calculate a, what do? I substitute the point that's lying on this graph, which is 3 and 15. That's the x and the y. So what do I have? 15 is equal to a into x, which is now 3 plus 2, into 3 minus 2, into 3 minus 6. This of course is going to be 5 times 1 times negative 3. A is equal to 15. Negative 3 times 5, negative 15, not so. Divide by negative 15 both sides. Negative 15, which gives me an a value of. But have I answered the question? I've only got a so far. Not so. So what do I have now? Y is equal to negative 1 into x plus 2, x minus 2, x minus 6. Which is negative. This is the conjugate pair. Multiply the first and the last. It's x squared minus 4. If you don't know the rule, people, please don't keep yourself brave. Multiply the story. Okay. So it's negative into. That's going to give us x cubed minus 6x squared minus 4x plus 3. Which then gives us negative x cubed plus 6x squared plus 4x minus 3. Is that correct? Alright, so the a value is negative 1. Your b value, of course, is going to be the coefficient of x squared, which is 6. Your c value is the coefficient of x, which is 4. And your d value, of course, which is a constant, is negative 24. Okay? It's easy, no? 4 marks and something else. Let's look at number 2. People, you can draw the graph as well if you want. I've done it in the examples. You'll also find it in the description box below the examples. Okay. People, in number 2, we are told f of x is equal to ax cubed plus bx squared plus cx plus d passes through the following points. What do you notice again? We have 3 x-intercepts and the graph is going through another point. Determine the value of a, b, c, and d. Very similar to the previous question. Not so. What is the formula here? Y is equal to a into x minus x1, x minus x2, x minus x3. Alright, so we go y is equal to a into x minus minus 5 becomes plus 5, x minus 1, and x minus 4. So how do I solve for a? Substitute the other point. So we'll substitute another points lying on this curve, which is 2 and 4. This is an x and a y. So 14 is equal to a into 2 plus 5, 2 minus 1, and 2 minus 4. Which now gives me a by 7, 1 and negative 2. You all agree with that? What is 7 times negative 2? Negative 14 divided by negative 14 both sides. So a is negative. People, it won't always be negative 1. Before you say, okay, next one, a is 1, negative 1. Is it by chance that these two works out to be the same? Have I answered the question? No. So what do we say? Y is equal to negative 1 into x plus 5, x minus 1, x minus 4. This is multiply the story out again, so it's negative into. That's going to give you x squared minus x plus 5 is plus 4x minus 5 into x minus 4. Multiply that story out, keep the negative on the outside, so it's going to give you x cubed. That's negative 4x squared plus 4x squared cancel. Okay, then negative 16x minus 5x is negative 19x. And then plus 20. Is that correct? There's negative x cubed plus 19x. Just check if that's correct. So according to this answer here, the b value of course is 0. Your c value is 19 and your d value is negative 3. Correct? Sorry? Correct. Okay. Any confusion there? Why do you guys do that homework? How much I have here? Right, so this is look at number 3. Yes? Not correct. Okay. So why did she say it's correct? Now how much I feel now? Okay, let's go. Let's just check here if I multiplied it out properly. Probably didn't. I was taking a shortcut now, doing part in my head. Which you mean to say my head is not right. So, there's going to be 4x minus 16x minus 5x plus 3. So it's going to be negative into x cubed, that cancels, minus 19x plus 3. What is the answer? Sorry? It is 21. 16 minus 16 minus 5 is 21 and not 19. That's my mistake. The loser mark there. So that's going to give you 3. Thank you, people. Alright, so in our next lesson, we will try and conclude more of this exercise. Okay? People, enjoy the rest of your day. Good morning, class. Okay, good morning, class. So today we're looking at exercise 12, dealing with calculus. In exercise 12, we're on page exercise 30. We're on page 174, but we're doing number 3 now. Okay. So I told to consider the function f of x equal to x cubed plus bx squared plus cx plus d. Determine the values of a, b, and b, c, and d if f of 1 equals f of negative 2, which is equal to f of f prime 0, which is equal to 0, and f of 0 equals negative 4. So to unravel this here, what we have is that if x is 1, y is 0. Then x is 1, y is 0. And if x is minus 2, y is 0, as you know, that is your x-intercepts. And if dash x or if dash 0 is 0, which means to say the turning point is at the x value of 0. It's not 0 and 0. Okay? So the turning point is at x equal to 0, and this is 0 and minus 4. X is 0, y is minus 4. So what is this here? If x, when do we let x equal to 0? You work out how? Y-intercept. So your d value is negative 4. But say we didn't know that. Okay. Let's go and say, okay, we'll substitute 0 and minus 4. Remembering that's an x and a y. F of x is a y. So negative 4 equals to 0, a into 0 cubed plus b times 0 squared plus c times 0 plus d. So d works out to be minus 4. Okay. Then I'm going to work with this first. So f prime x, f prime 0 is 0. So if f of x is ax cubed plus bx squared plus cx plus d, then f prime x is equal to 3a x squared plus 2bx plus c. So what do we say? F prime of x is 0. So the turning point is at x equal to 0. As I said, that is not a coordinate, but this is f prime x. So f prime of 0 is equal to 3a times 0 squared plus 2b times 0 plus c is equal to 0. I can drop this. That means to say c is 0. So I got my c and I got my d. Alright. So my equation now reads f of x is equal to ax cubed plus bx squared, cx is gone, minus 4. So what do I need to still solve? A and b. Can you see that? So what do I notice? I have 2 points that I haven't used yet. Okay, so what I'm going to do is I'm going to substitute. I'll take this off here. So D is negative 4 and C is 0. Okay, I just need the space here. Okay. So what do I do now? I substitute 1 and 0. Remembering again that's a x and a y. So 0 is equal to a into 1 cubed plus b times 1 squared minus 4. So I'm going to make a, keep a on the right hand side, bring everything over, so it's minus b minus plus. So this is equation 1. Why am I labeling equation 1? Because it's going to go into simultaneous equations. Now we will substitute the other point, which is negative 2 and 0. Okay, so that's a x and a y. So 0 is equal to a times negative 2 cubed plus b times negative 2 minus negative 2 squared minus 4. So of course this is going to be 8a plus 4b, negative 8a plus 4b minus 4. That's the equation. I can actually go further and divide everything by 4. We'll agree with that? We'll make the sum a bit easier. So divided by negative 4, or just 4. So it's going to give you 2a minus b plus 4. And this is equation 2. So what I do is, if I see an a, I put a negative b plus 4. You all agree with that? So my equation now reads 0 equals 2 into negative b plus 4 plus 1 minus b. So minus b plus 1. So I get rid of the brackets there, multiply out, so 0 is equal to negative 2b plus 8 plus 1 minus b. That's going to give you minus 3b. Not so. Bring it over, becomes positive 3b is equal to 9. B of course is equal to. So what do I do now? Sub it back. So I put this into equation 1, y into equation 1. A is already the subject of the equation. So therefore, A is equal to negative 3 plus 4, which is, so your A value is 1, your B value is 3, your C value is 0, and your D value is negative 4. Is that correct? Any questions? Again, something like 6 or 5 or 6 marks on that side. Pupil number 4 of exercise 13. We are told to consider the function f of x equal to ax cubed plus bx squared plus x plus d, and determine the values of a, b, c, and d if f of 2 is equal. Again, is this. So if f of 2 is equal to 0, that means to say there's a coordinate 2 and 0. This is f dash x. So this has a turning point at x is equal to 1. That's basically what it means. Okay? Then this has a point of inflection. No, another point of inflection. If this was equal to 0, it would have been a point of inflection and x equal to minus 2. Not so. So, this is if double dash of negative 2 is equal to negative 17. We need to pick up a negative 2 again some way. Because there seems to be a turning point. Looks like a maximum turning point. Okay? But we are told that if double dash of 2, yes. So this is going to be a maximum turning point. And of course, the if double dash of 2 is equal to 7, that means to say this is a minimum turning point. Okay. So the question says determine the value of A, B, C, and D. Okay, so where do we start? Let's start with this here. Okay. So if double dash, so I have to first find the derivative and then again the derivative. Not so. So we find the first derivative. So if dash of x is giving us what? 3ax squared plus 2bx plus 6. Now I find another derivative, which is 6ax plus 2b. That's your second derivative. So let's go with the first bit of information. We know we are given that if double dash of negative 2 is equal to negative 17. Okay? So wherever I say x I put negative 17, wherever I say if double dash of negative 2 I put 17. Negative 17. So I say if double dash of negative 2 equals. Wherever I see x, I replace it with negative 2. So 6a times negative 2 plus 2b. And this is equal to negative 17, which is this here. So it's going to give you negative 12a plus 2b equals negative 17. And this is equation 1. Okay. Let's look at the other bit of information. We are given that if double dash of 2 is equal to 7. So this is actually not the maximum. I'll show you when I'm done here why not. Otherwise it will give me 2 bits of information here. Sorry about that. So if double dash of 2 is equal to 7, so wherever I see x I put a 2. So it's 6a into 2, I'm going into this equation, plus 2b equals So it's going to give you 12a plus 2b equals 0. And this is of course equation 2. Now I can go with making b the subject of the formula in either case, and then working with fractions. Or I'm going to do what I was taught in grade 10, which is simultaneous by elimination. As you can see, both are linear equations here. So it's going to be negative 12a plus 2b minus 17 equals negative 17. Put the other one below, which is 12a plus 2b equals 6. So what do I do? I add this up here, that of course cancels. I'm going to get 4b equals negative 10. So I'm getting b to be negative 5 over 2. Let's check if that's correct. Is b negative 5 over 2? Huh? No. Give me a shock. Okay, so b is negative 5 over 2. So what do I need to solve now? I need to solve for a. So substitute that back into one of these two equations. So I said in 12a plus 2 times negative 5 over 2 equals 7. So I get in 12a minus 5 equals 7. You take that over, gives you 12. So a gives you an answer of 1. So a is 1. So a is equal to 1 and b is equal to negative 5. Okay. I just need to clear this board here. Probably 7 marks on something else. Okay. Alright, so this was just calculated. So the next question, the next bit of information, we know that the graph has a turning point at 1 and x equal to 1. So my equation now should read if prime x equals, if a is 1, 3 times 1 is 3. So it's 3x squared. If b is negative 5 over 2, so that's going to give you negative 5x. You all agree with that? And plus c. C is unknown at this stage. So of course you can substitute this bit of information in here. So we know that f prime of 1 is 0. So f prime of 1, if I see x up with a 1. So it's 3 by 1 squared minus 5 times 1 plus c, and this is equal to 0. So I drop this. So I get 3 minus 5 plus c is equal to 0. C is 2. Not so? So c is 2. Okay. And now you see what still needs to be solved? A. It's the last thing I need to solve here. Not so? No, not A. D. The last thing I can. So we got A, we got B, we got C, now we need D. Also note that I went as far as the second derivative, then I work my way up to the basic, or the points that the graph is actually going through. And that is always the route that I'll follow. Okay. So my equation now reads f of x. So this is a and c is equal to 2. As you can see, I need to space again. So we know that f of x is now equal to what was a? 1. So it's x cubed minus 5 over 2x squared plus 2x plus 3. Okay? Yeah, it's going with that equation, the original. So what do? I substitute 2 and 0. That's an x and a y. So 0 is equal to 2 cubed minus 5 over 2 squared.
The following learners can please make your way to Ms. Mpulanga's classroom Sion Lise, Ludidi,
To excuse
Ubasa Plagi,
5 over 2
Flonella,
times 2 squared.
Imanati, and Sasona. Can you please make your way to Ms. Nubagalanga's classroom for your Isikosa period?
Okay, so that gives you an answer of the 2. Is that correct? So then therefore, D is equal to? Let's check if that's correct. Remember earlier on I was looking for additional information for that negative 2. If I had found that f prime of 2 is equal to 0 or f prime of negative 2 is equal to 0, it would have been safe for me to say that this is the local maximum. Okay, but because that information was not given, it's not fair for me to have said that this was the local max and the local minimum. Okay. All right. Then number 5. And then number 5, you are given number 5, you are told that f is a cubic graph with f of 3 equals f of minus 3, which is equal to f of f dash 3. F of f prime x, the sketch alongside. Do I have the sketch here? I'm going to get the sketch. Okay, so f is a cubic graph with f of 3. Okay, so with that information here, f of 3, f of minus 3 equals f prime of 3. F prime x is sketched alongside. So that means to say that, you see, this is f dash x, this is your first derivative. So that brings us to the train of thought that if a is less than 0, if a is negative, then your parabola is frowning. The graph first goes down, then up, and this the second derivative does that. We'll agree with that, no? So this is your function, this is your f prime of the function, and if this is the f double prime. Alright? So if you're looking at f prime of 3, what happens at f prime of 3? This is actually 0 here. Not so, because the x-intercepts of your first derivative is actually the turning points. The x values are the turning points of the original function. So in other words, this is equal to 0 here. Okay. State the coordinates of the stationary points of f and classify the stationary points. So this graph is first going down, then up. So negative 1 would be the local max or local min? Local minimum. Whilst 3 will be the local max. So at x is equal to 3, f of x will have a local maximum. And at x is equal to negative 1, f of x will have a local minimum. Can you see that, people? That will be at the bottom, and of course at the top. Okay. And 5.2. In question 5.2, we are asked to state. Pull this up here. State the x coordinate of the point of inflection and justify your answer. So the point of inflection will happen midway between the 2 points of the two turning points. Not so. It happens normally there, the midway between the two turning points. So the turning points, of course, is negative 1 and 3. So midway is going to be there. Not so. So what I do for 5.2, it's going to be negative 1 plus 3 divided by 2, which gives an answer of 2 over 2, which is 1. So x is equal to 1. And your justification or your to justify your answer, you would say that your two turning points, your point of inflection will occur between the two turning points. Okay. Let's look at 5.3. Discuss the concavity of f. Yeah, I ask you to discuss the concavity of f. And explain your answer fully. So in 5.3, so we know that this part of the graph is concave. This part of the graph is concave. So what is this x value here? X is equal to 1. So as x is less than 1, the graph is concave. For x is greater than 1, the graph is concave. Yeah. As you can see, this part of the graph is concave. Okay. How can we justify the answer? We can say since a is negative, or a is less than 0, therefore the minimum precedes the maximum. Okay, so on the left hand side, of course, is concave up, and on the right hand side is concave down. What does the textbook say? Sorry?
It is from concave up to concave.
What? Yes, read somebody. If double prime of x
is more than 0,
yeah,
if x is less than 1,
x is less than 1. So as you can see here, x is less than 1, and we see that is concave up. Sorry? Just hang on. So you're saying that if double dash of x is greater than 0, if x is less than 1, therefore concave up. Okay, is that what it says? Okay, it's read out loud.
There is a comment that says if double prime x is equal to 0, if x is equal to 1. And
If double prime of x is equal to 0,
if x is equal to 1.
if x is equal to 1, that's of course coming from this question. Okay?
And if double prime x is less than 0.
If double prime of x is less than 0,
If x is more than 1.
if x is more than 1.
So f of x changes concavity and x is equal to 1 from concave up to concave.
Okay. Okay, if you want to use that, you can use that as well. Okay. But in the exam, they just ask you about concave up, concave down. Okay, and the point of inflection. They don't ask you to explain this. I think when you're going to draw x to the power of 4 graphs, then that will come more into play there. Okay. Then you need to test whether the graph is actually concave up and concave down. Okay, well, this is fairly simple to us. Then in 5.4, they ask you to sketch this graph. Okay, 5.4, they ask you to sketch this graph. This is there. So, we know that the graph is going to turn at x equal to minus 1 and x is equal to 1. So we know that the graph is going to go first down.
Good morning, may I have your attention please? All choir learners, can you
Okay.
please report to the hall now?
So this is your f
All
of x.
choir learners to please report to the hall.
So people, did they tell us this graph is going to cut the x-axis thrice? No. Did they tell us it's going to cut twice? No. Did they tell us it's going to cut once? No. So if you draw this graph anywhere along this curve, Can you see that, people? Anywhere along this, you're going to get a full mark for the graph. You guys understand? But if more information was given, say they tell us that the graph is going through an x value of 2, your x-intercept is 2, then I would have to let it cut. This has to cut here somewhere. So something like that. Then I would have put 2 here. Can you see that? But because this is all that is given and I've indicated all information, all I can just add here is that this would be your point of inflection at x is equal to 1. Okay. People, you guys understand? Any confusion there? Okay, so tomorrow we will look at the remaining 5 sums. Okay, so now we're going to go into some optimization.